Department of Computer Science and Engineering, and the topic I am going to take is from the subject Computer Networks. The subject code is CS85. Concept of transmission control protocols. Correction. The format of the transmission control protocol is an connectionless packet service IP. Above that, we will be having the reliable stream protocol, unreliable transport service UDP, and the application services telnet, FTP, email, and TCP. What it is. So TCP is a protocol that specifies how to distinguish among multiple destinations on a given machine, how to initiate and terminate a stream transfer, format of the data and acknowledgements two computers exchange to achieve a reliable transfer, procedures that computers use to ensure that the data divides the data stream into segments for transmission. We will be having source port and destination port, sequence number, acknowledgement number, header length, its reserved is 4, and the code bytes is adjoint pointer is for 8 bits. Options if any, then padding and data. Code bits identify the content of the segment. So bits from left to right, adjoint pointer valid, acknowledgement for field is valid. Push this segment across the push. Reset the connection. Synchronous sequence number. When is the sender has reached end of the byte stream window, how much data the sender is willing to transfer. Specify the position in the segment. TCP provides a mechanism to handle urgent data. TCP provides a mechanism to handle urgent data. Urgent data is received before the octets are already in the stream. Sender sends urgent data in segment header, puts urgent data at the beginning of data field, sets urgent pointers to the end of the urgent data. Receiver notified of the urgent data. As soon as the array enters urgent code, until all the urgent data has consumed, returns to options. Checksum used to verify the integrity of the data computed over segment header, segment data, and pseudo header. So one complement addition algorithm. So signal varies option. Cumulative acknowledgement scheme. All octets up to, but not including number 7 have been received correctly. Advantages: acknowledgements are easily to generate, unambiguous. Last acknowledgement do not force retransmission. Disadvantages: do not receive information about all this. When the timeout will takes place, start the timer and wait for the acknowledgement. Retransmit if the timer expires. TCP uses an adaptive retransmission algorithm because internet delays are so variable. Round trip time is the connection is the time taken from sending the data and receiving the data, and the time to get the acknowledgement to the sender. For each connection is recomputed every time an acknowledgement arrives. Timeout value is adjusted accordingly. Alpha multiplied by RTT round trip time. This one minus into RTS ready to send. Minus A is equal to 0, minus A equal to 1. How should RTT can be calculated to compute a timeout? Timeout is equal to B multiplied by RTT minus B equal to 1 minus B greater. So difference in time segment sent and time acknowledgement. But what about retransmission? That acknowledgement corresponds to first or second copy of the segment. Assuming acknowledgement is for the earliest transmission causes problem. Assuming acknowledgement for the latest transmission causes problem. TCP acknowledgement timeout will be C is equal to new timeout is equal to C multiplied by trip estimate. Ignore samples that correspond to retransmitted segments, but use the back of track strategy and retain the timeout value from retransmitted timeout source. Delay. So round trip time is not useful, but the internet delay tends to have higher variance. Most TCP implementation estimate, average round trip time, variance, timeout signal B usually length and delays. Its response to length and delays, retransmission causes congestion collapse. So it reduces receiver advertisement, congestion. Retransmission, so slow start increase, multiplicative decrease, congestion avoidance, measurements for RTT round trip time and variation. So exponential connection, you have to request the connection, you have to, if the receiver, the sender is also receiver is ready, you have to establish a connection, you have to raise the connection. So let both sides to agree on the scene transmitting data and waits for the acknowledgement from side 2. Side 1 transmit a segment with the FA and bit segment, 2 acknowledges with the segment. Receive and acknowledge data from side 2. Eventually side 2 will finish transmitting and send the sequence number, receive it, acknowledgement, and the receive acknowledgement, and the so the broken connection can be reset if site 1 sends a segment with the R set, reset bit set, site 2 receives a segment and aborts the connection. Transfer in both directions is immediately. Sources for the connection are released. Application TCP divides the stream of octets into segments. So TCP provides a push operation for that the delivery of the octets, set push bit and set reserved UDP. Port numbers are accessible by both UDP and TCP should match. Echo will be 7, time will be 37. So UDP, the ports 0 to 1024 are reserved. Port number 1. TCP ports are 80 for HTTP, 25 for SNMP, 21 for FTP, 23 for performance. Silly window syndrome. Sender generates data quickly, receiver reads incoming data. Advertises a small amount of space. Problem. Reliable stream delivery service, full duplex, out of band for urgent data. Makes efficient use of the network. Picky bagging, sliding windows, efficiency, end-to-end flow control, acknowledgement and transmission, congestion. TCP. What are the services provided by TCP? Explain in detail about transmission control protocol. Thanks for listening. Thank you.